add a couple more questions. So, I affectionately call these problems, tree killer problems, because they just take up a lot of space and a lot of time. So it doesn't mean it's too hard to do, it just means you need to kind of be aware of that. The good news is I wouldn't put any more than like one of the 3 variable questions on a test because they are time consuming. I mean, so if you look at your homework for this section, there's very few problems that are 3 variable, and that is because, again, they just take a long time. So let's take this system. Notice the numbers are kind of larger, and so I wanted to do one where maybe the numbers were a little bit uglier, because on MyMathLab it tries to give you different questions than the person sitting next to you, so it is possible that at least one of your questions will have larger numbers like this. Okay. So remember, the first step is you just decide, you either need to think this in your head, but you just need to decide which variable needs to get eliminated first. So, and there's really no right answer here. So I think I got rid of x last time, so I'm going to get rid of y this time. But if you have trouble kind of getting lost in your steps, it's a good idea to write down what you're going to eliminate first. Okay, so you're going to line up 2 equations, and you're going to do just what we said we were going to do. We're going to try to eliminate y. So I'm just going to take the first 2 equations. So if I want to eliminate y, like I said, what do I need to do to the second equation? This number right here needs to be able to cancel with the 6, so I need to multiply it by a what? So what would cancel out of 6? A -6, right? So I need to multiply by -3. Okay, so this is what you end up getting, or what you should end up getting. The first equation doesn't change. And the second equation, you're going to get -9x minus 6y plus 15z equals 66. Make sure you multiply everything through by the -3. Okay? And so you're going to get the 6y's to go away just like we wanted, and then you end up with -5x plus 29z equals 92. So I'm going to circle this because this is going to move on to the next step. Okay. But I need something to pair with that. Like, I can't just look at that by itself. So this is when you combine another pair. So remember, the rule is combine 2 pairs of the 3 variable equations and get rid of the same variable each time. So I'm going to pair the second and third equations this time. So when you line them up like that, what's the first number that goes into both? Or that 2 and 7 both go into, I should say. 14's the smallest thing, right? So we're going to need to multiply this times 7 or -7. But since I did this one by a positive, I'm going to do this one by a negative. Because remember, you want one of them to be the positive number, one of them to be the negative number. So use a calculator if you need to, but 21x plus 14y minus 35z equals -154. Is what you should get. And then double everything, but also change the sign here. So -10x minus 14y plus 6z equals 56. And again, we're combining these. And notice we're getting rid of the same variable both times. Y is going away here too. So we get 11x minus 29z equals -98. Okay, and I'm going to circle this. Because now notice here and here, I have 2 equations with only x and z in them. Okay, so now I'm just going to combine these together. That was the whole point in the 2 steps that I just did, was to eliminate the y so that I only had 2 variables left over. So now let's stack those 2 equations up. And notice sometimes you get a bonus here, because what do you already notice? With no extra work, what's already going to happen if you just add them as they are? It just so happens that what's going to get canceled if you just add them as they are? The 29 z's, right? So you're going to get 16x, sorry, not 16, right? And so I did the same thing again, right? I didn't copy down my negative sign, which is why some of you probably were looking at me like that. Should have been a negative 5, so that would have been a 6x, and then equals negative 6. So I don't know why I can't copy down numbers right. So you want to make sure you don't make sign errors, and I guess you want to make sure you copy down the numbers correctly, like I can't seem to do. So we've got x equals negative 1. That's a third of the answer. We just need to find y and z. Okay. So the next thing is we're going to find z. Because I have an equation with just x and z in them. So I'm going to use this one maybe. But it doesn't matter which one I use because remember it's supposed to work for both. So plug in negative 1 for x. And then see if you can figure out what z is. So this would be plus 5. So to get rid of it, I'm going to subtract it. So I'm going to get 29z equals 87. Remember what I said, you shouldn't be getting crazy numbers. You should be getting nice, pleasant numbers for the most part. And this does work out nice. This works out to be z equals 3. 87 divided by 29 is 3. So I've got 2/3 of my answer. So what's my final step then? So what's the one that I don't know yet? I know x, I know z, I don't know y yet, right? So pick an equation, I don't care which one. I'm going to pick the second equation because it looks to me to have the smallest numbers. That is really the only reason I picked it, but you can pick anything you want and then plug in the x and the z and see what the y would have to be. So 3 times negative 1 plus 2 times y minus 5 times 3 equals negative 22. Don't get all the way to this stage and then make a goofy sign error, okay? So if we combine these, this is going to look like 2y minus 18 equals negative 22. And then we can just add 18 to both sides. So we get 2y equals negative 4. And then divide both sides by 2, so we get negative 2. So in the end, remember, I want you to write the solution as an XYZ number. So negative 1, negative 2, 3 is what you should have gotten. Okay. And if you're on a test or something like that, what can you do to make sure that you did it right? Plug it back in, right? So I'm just going to say plug it back in to check, but we're not going to do it for time reasons. So if all you're doing is either on the video or in person watching me do this, it is not the same as doing it yourself. You actually need to tackle one of these problems and see if you understand it as well as you think you do when you watch me do it. Okay? Because there is a disconnect between watching someone else do it and doing it yourself. So it's not the same. Okay, so I want to do one more. So let's say I told you to solve the following. So I want you to make sure that you can do one where maybe it looks like there's some terms missing. Notice that when you see this, it will probably be spaced out like this because we like to keep like terms together. So first equation doesn't have a z, second equation doesn't have an x, okay? But we're not going to treat it any different. We're still going to decide on which variable we're going to get rid of first. So I'm going to eliminate z first. To be honest, because I already have an equation that z is gone for, okay? So that's why I'm going with that. So notice that I really just need one more equation to add with this one that would have z gone, right? So I'm going to line up the two equations that have z in them. And I'm going to ask myself, right, if my goal is to get rid of z, what do I need to multiply the first equation by to make that happen? If my goal is to get rid of z, what should I multiply the y minus z thing by? So if this is 3, we want that to be -3, right? So we'll multiply by 3. So this is what we'll get. We'll get 3y minus 3z equals 3, and 2x plus y plus 3z equals -21. So just like we said we wanted here, right, we're going to get rid of z, and then we've got 2x plus 4y equals -18. Okay, but now I need something to combine with this, okay? So I'm going to combine with this, the following equation. We already had one that was just x and y already, right, the first equation? So I actually have less work to do on this one, so now I'm going to line up 2x plus 4y equals -18, and x plus y equals -4. Okay, so notice, if I wanted to get rid of x, right, what would I multiply the equation by? -2. What if I decide instead to get rid of y, which I could do? It's actually fine. -4. Okay, so just pick one. I'm going to do -2 just because it's smaller. So I'm going to get 2x plus 4y equals -18. -2x minus 2y equals 8. Remember, everything gets multiplied by that -2. So just like I wanted, x is gone, and now I've got 2y equals -10 for y. So when I go to divide by 2, I get that y is -5. So I've got a third of my answer completed. Okay, so now I just need to pick one, and honestly, it really doesn't matter. I'm going to choose x first. Okay, so look up top. What is the best equation for me to use to try to figure out what x is? There's a really pretty short one, right? So I'm going to use probably this x plus y equals -4 one, because that's going to be really pretty quick. So x plus -5 equals -4. So all I need to do to find x is just add 5 to both sides. So I get x equals 1. And then last but not least, now I just need to find my final one, which is z. So I can use the last equation, or I can just use the second equation, and that's what I'm going to go with, because it's shorter, it's nicer, and we want to make it easy on ourselves if we can. So you get -5 minus z equals 1. So just be careful about the sign details. You would add 5 to both sides, and that's going to give you -z is 6. But I don't really want -z, right? So what do I have to do to both signs then? Change them, right? I'm essentially just dividing by -1. So z is actually -6. Okay. So in the end, I get my solution, which is 1, -5, -6, and just like the others, I can check this by plugging it back in if I so choose to.
So when you have terms missing like that, you're not actually trying to like find what the terms are, you're just still solving it?